Hello, my beautiful friends. This is Mrs. Schlecht, and in this video, we're going to go over how to divide integers and rational numbers. All right, so you know that there's going to be a few materials you need in order to be successful for this activity. First, you're going to need your Envision textbook. That's the one with that little robot on the front. Second, you're going to need your math notebook so you can take those beautiful notes and show me all of your wonderful math learning and thinking. Third, you're going to need that pencil. And fourth, last but certainly not least, that positive math attitude, because you are a big, brilliant, smart person and you are just going to do amazing things. All right, so before we get into all the cool math stuff, I just wanted to let you know, my friends, that this video actually covers two separate lessons in your math textbook. The first is lesson 1-8, and that really focuses on just dividing integers, and we'll kind of talk about that pretty quickly because if you remember, the same rules for multiplying integers, pretty similar. But the second part is lesson 1-9, and that, my friends, it's not scary, it's not, anything that you can't do, but it is a little bit trickier, and that is how to divide rational numbers. And I'm going to be able to share with you a cool story about something that Mrs. Schlecht learned even in my old lady age while I was actually preparing for this video. But first, let's take a peek at lesson 1-8. All right, so here is the most simple, most beautiful thing of this entire lesson. If you remember from multiplying integers, when I had a negative times a negative, my answer was positive, right? When I had a positive times another positive, my answer was also positive. But when I multiplied a negative times a positive, then my answer was negative. If you don't remember, please make sure that you go back to lesson 1-6 and lesson 1-7 because it goes over those sign rules for integers. And my friends, here's the super cool, awesome part. Same principles apply here. So your regular division steps that you've been doing since third grade, still same, still there, still something that exists. But that new piece that you picked up in multiplying integers that helped you find out what sign is what you need, same system, same process for dividing integers, which makes my life so much easier, so nice. So again, key concepts for lesson 1-8, which again goes over dividing these integers, can be found on page 56. And on page 56, you'll notice underneath that key concepts box, there's also a couple of different practice problems, and that, my friends, is what we're going to spend some time to look at really quick. So I would love for you to please open your book to page 56, and we are going to be looking at problem number 4. All right, so let's take a peek at the first two portions of number 4. So again, page 56, problem number 4, part A and part B, we're going to start by looking at. So the first one, my friends, is 18 divided by -3. So first, let's forget about the sign, and let's just think of what's 18 divided by 3. If you can't remember what 18 divided by 3 is, just flip it and use your fact family. So you can think of 3 times what will give me 18. You're right, it's going to be 6. So again, 18 divided by 3 is 6, but my friends, now we're dividing integers, right? So that tells me that I need to see what type of sign that this 6 should be. Should it be a positive 6 or a negative 6? Let's check back at our problem. Notice that we have a positive number divided by a negative number. And remember, my friends, if we are dividing or multiplying those integers that have opposite signs, then your answer is also going to have that negative sign, right? So 18 divided by -3 is -6. Now let's look at B. In B, we have a -5 divided by a -1. Notice that these signs are the same, negative on top and negative on the bottom. And now just think of basic math. Well, what's 5 divided by 1? That's 5. And since, my friends, we have a negative divided by a negative, this is going to be a positive 5 is my answer. All right, my friends, so now we're going to look at part C and part F for, again, problem number 4. Part C is 24 divided by a -6. Now again, think of your fact families. You know that 24 divided by 6, positive or negative, that part doesn't matter, is going to be 4. That's your fact family. But now let's think. Is that going to be a positive 4 or a negative 4? Ta-da! It's going to be a -4, but you already knew that. you saw that in our original division problem, we had a negative and a positive number that we were working with. Therefore, since those signs were not the same, my answer is going to have that negative number next to it, right? -4. Notice I'm skipping all the way to F now. So this is 4F. We have a -8 divided by 2. Well, you know this. Think of your fact families again. 8 divided by 2 is 4. But let's see, will that be a +4 or a -4? Well, I have a negative integer and a positive integer. And remember, when my signs do not match up, then my answer becomes negative. So -8 divided by 2 is, ta-da, -4. Pretty cool that both of these problems look different, but they get the same answer, right? So again, -8 divided by a +2 is 4. So friends, that is really what lesson 1-8 goes over. It's just you're dividing again, but this time with integers. Remember those sign rules and you'll be all set. All right, my friends, so here is some interesting stuff. All that's previous stuff we just talked about, all from lesson 1-8, right? And it really just goes with your division skills and remembering your integer sign rules, right? But here's a new piece that even Mrs. Schlecht learned when I was looking over stuff for this week. Either I learned it in 7th grade and I just completely spaced on it, or I'm relearning it for the first time. No idea, but it's super cool. If you check out page 61, there's this new term called a complex fraction. Complex fraction. Now, I know about mixed numbers. Man, I can do mixed numbers all day long. But complex fractions, when I first read that word, my friends, I was like, what the heck is that? So, little kind of funny story. I told Mr. Schlecht about my new discovery, and Mr. Schlecht, who is like super duper smart, can do math like left, right, backwards, upside down, all over the place, right? He told me, that's like really easy. How do you not know what a complex fraction is? And I said, whoa, man, because I didn't know what it was. And that's okay. It's okay not to know something and then relearn it, right? So I might be a little bit, tiny bit older than you, probably like a lot, but I learned something new. So I want to share with you this cool new thing that I learned about called complex fractions. And again, my friends, these can also be found on pages 61. This goes with lesson 1-9, but also that key concepts page is on page 62. And that is also a great place to look for those tips, those helpful hints, right, about how to solve these rational numbers division problems. But since you are also brilliant, I really want to look at how in the world do you break apart a complex fraction. So let's take a peek. So first, before we start getting into how to solve this, let's just talk about what a complex fraction is. So a complex fraction is where you have a fraction in your numerator and or your denominator. So before, my friends, we just saw them as mixed numbers, or we just saw them as a fraction with one number in the top and one number in the bottom. But a complex fraction, it's like complex and stuff. It's got so many different things going on. In this case, we'll have a fraction in your numerator and a fraction in your denominator, or actually a mixed number in this case, right? So full disclosure, when Mrs. Schlecht first saw this, I had those alarm bells going off. I had that, what is happening thing. But then I remembered my lovely 8 math practices, which are right down here, and one of which tells me to connect new stuff to my old stuff. So this is how Mrs. Schlecht's brain was working. I remembered that fractions are just division. So I rewrote this problem. Instead of a division problem like this, I decided I'm going to change the look of it. I didn't change the value, but simply I changed it to make it into a format that I can work with and actually makes sense to me. So we can also rewrite this equation or this complex fraction as, I can also write it like this. So now I have a division sentence with -2/7, which is the same as my numerator up here, divided by 1 1/3, which was the same as my mixed number, which was in my denominator over here. But now, my friends, this is in a format I can actually kind of work with. Do you remember when you were dividing fractions, those 3 special words that you can keep in mind? Keep, change, and flip. Okay, my friends, so down here, I now have my division sentence written as a multiplication sentence, and I used that reciprocal for my mixed number to help me be able to do this. Again, my friends, the value of all 3 of these expressions all the same. All we did was we changed the format to make it easier for us to actually work with. One thing I wanted to point out, notice that we had a mixed number over here, but don't forget, my friends, you need to convert that into an improper fraction, which you would do 1 or 3 times 1, which is 3 plus 1 would be 4. So this improper fraction would be 4/3, again, which is the same as this mixed number. So then what I did is I did my keep. I kept -2/7, that's the same. My change was my operation sign. I changed this from a division problem to a multiplication problem. And then third was that flip. So again, I took the reciprocal of my mixed number. So again, when I had my mixed number, I wrote it as an improper fraction. I got 4/3. Then I used the reciprocal for that, and that got me 3/4. Real quick, my friends, if this part went too fast, just rewind it, watch it over again, or let me know and I can help you out. But now that this is in a multiplication sentence that I can actually solve, now I can just do some cool math. So we have a -2 times a +3, a -7 times a +4. So that would look like, all right, my friends, so I did my multiplication and I got -6/28. And we know I can simplify that. So this fraction, I can divide 6 by 2, I can divide 24 by 2. So we could also rewrite this fraction as, we can also write it as -3/14. Again, my friends, all of the same value throughout this entire problem, but we took that complex fraction and we reworked it, we rearranged how it looked so that we put it in a format that we can actually work with, that actually makes sense for us, right? Let's take a peek at another one. We're still on part 5 on page 62, but let's look at part B. All right, my friends, so again, this is part B for number 5 on page 62. We have a negative fraction over a positive mixed number, similar to that problem that we just did. So remember, first, I'm going to rewrite this as a division problem. So all I did was I just wrote this as a division problem now. Again, same value, my friends. We're just changing the look of it so that it's in a format that we can actually work with. So now I know that I need to convert this mixed number into an improper fraction so that I can continue. So remember, you do 4 times 2 plus that 1. So 2 1/4 as an improper fraction would be 9/4. All I did was I just rewrote our problem down here. I took my mixed number and I wrote it as an improper fraction. Again, my friends, I have done not a whole lot of math at this point. I'm still just playing around with these numbers so that I can put it in a format I can actually work with. Now that this is in a, I have a fraction divided by a fraction, I know I can use my keep, change, flip rules to help me multiply by the reciprocal so that I'm able to get an answer for this. So keep, we're going to keep -3/5 the same. Change, we're going to change this problem from a division problem to a multiplication problem. And flip, that refers now to my improper fraction. I want to flip it to get the reciprocal, which would just be 4/9. All right, so now I have our division problem, but I just rewrote it using multiplication. Again, don't forget about that reciprocal. And now, my friends, we can just multiply. So we have a -3 times a +4, and -5 times a +9. So that would get us, so my friends, that would get us -12/45. All right, my friends, so we know that we're able to simplify that -12/45 into 4/15, but it's still negative, remember, my friends, because we had a negative integer, we divided it by positive. Since those signs are not the same, they didn't agree, your answer needs to become negative. All right, my friends, that was just a little video over lesson 1-8 and 1-9. Remember, those lessons went with how to divide integers and rational numbers. Don't forget about your sign rules. Those are still the same as they were when you were multiplying. And those complex fractions, I know they look really confusing, but break it down, my friends. You can do it. And as always, let me know if you have any other questions.